Hi there, welcome to my talk. Today we're going to be talking about continuous integration tips and tricks. These are the tips and tricks I have gained through my experiences on building CI/CD pipelines all over the world and doing public speaking on these topics. Today's talk is aimed at people from all different areas of IT, from software engineering to test engineering to DevOps engineering. Whether you're a beginner or advanced at CI/CD, I hope there will be value for you in this talk. If you have any questions, you can ask in the chat here at CDCon, and at the end of the talk, I'll have a live Q&A session where we can have conversations. Also, you can reach out to me on Twitter and email also, and I'll leave my details at the end of the talk. Today, we're going to discuss a number of relevant topics that cover architecture, development, speed, infrastructure, debugging, security, and tips and tricks. Nice to meet you. Before we begin the talk, I'll just briefly introduce myself. My name is Dragoonis. I'm a software engineering consultant. I'm from Scotland. I'm a public speaker, a trainer, and a coach. I also contribute to open source projects. I've been doing this for many years now. Some of the projects I contribute to are being part of the PHP team, the PHP Fig standards body. I'm a conference organizer. I help out with the Jenkins project in areas such as Blue Ocean and Jenkins X, and I'm part of the Continuous Delivery Foundation, and that is who this conference is organized by today. My experience that I have gained through my career has been gained from working in positions within engineering teams. I'm a quality engineer, and sometimes I'm a QA lead. I work as a test engineer, a DevOps engineer, or a build engineer. I work as head of engineering, a CTO, a software architect, a back-end developer, and a front-end developer. Now, this is relevant because I have the experiences from the perspectives of each individual member that comprises of most software engineering teams. And I'm able to take that experience and build pipelines that satisfy each team member's requirements. Despite having all of this experience, we're all in this together, and on a daily basis, I know I go from the two states of every programmer, going from thinking you're awesome because you just succeeded and you built something and it's working, to having no clue what's going on or what you're doing. And the more you learn, the more you realize there is more to learn. So let's dive into the talk. This is ideally the dream of what a pipeline should look like in theory. But a pipeline is a reflection of the business processes and the technical processes coming together. And there's usually different technical teams, from an infrastructure team to different development teams, and they all have to come together under one hood, which is the CI/CD. So it ends up looking more like this. And basically, it's really hard to manage this because we're trying to manage humans and machines in terms of automation. Here is an example of a pipeline that I have built for a large company. This is quite a typical pipeline in terms it has an initialization phase, a static analysis phase with linting, then doing Docker building to get images, then doing unit tests, and then moving on to higher level tests such as business value testing, functional testing, API tests, and user interface testing. When you're using Jenkins, I recommend using either the EC2 plugin or the Kubernetes plugin. Both of them are for different types of use cases, but I recommend using the EC2 plugin because it's probably what you're most familiar with. You're familiar with a Linux server, and it's probably going to match your local environment on your machine too, so you have consistency between your local and your CI environment. I recommend using Spot instances because they're very cheap and cost effective. And I also recommend having different types of instances that you can access using labels in your Jenkins files. With the label, you can target the right type of machine for the right type of job that you're running. Build concurrency. So build concurrency is when you're defining how many executors are on each machine. So Jenkins, if you set your smaller machine sizes that are more suitable for CD pipelines to 4, therefore Jenkins will schedule up to 4 jobs on your machine. Therefore, in theory, your jobs will receive 25% of the available CPU and hard drive. In terms of CI pipelines, it's more appropriate if you have 1 executor per worker on your large instances, and therefore your CI pipelines will have 100% of the available CPU and IOPS. Now that we're finished with talking about hardware and infrastructure, we can come back up to talking about the pipeline itself. Again, here is an example pipeline. And when Jenkins is actually operating, there is a setting in Jenkins that you can activate, which you can change from the default, which is max survivability, to performance optimized mode. So this will change the whole of Jenkins, the way in which the main Jenkins master is working, and how that master is interacting with the workers. Now, by default, it's max survivability, and that's more suitable when you have masters or multi-masters involved. But I would say about 90% of all companies using Jenkins do not need this, and therefore you can actually enable performance optimized mode. So Google search for this, find the setting, and switch it. And I recommend this. In order to make Jenkins responsive to the point where you push to your branch, or when you merge a pull request and it has a get trigger, you want your pipeline to start executing as quick as possible. In order to achieve this, you should disable tagging, you should disable getting the tags, and disable the git history by doing a shallow clone. Because in the context of CI, you don't need all of the history of your git repository, you just need the code at that point in time. And so by activating these 2 settings, this will make things much, much faster. Here is an example of a smaller and simpler pipeline. You'll see at the beginning we have an initialization phase, and then a Docker building phase, and then unit testing and functional test again. Here in the initialization phase we have cleaning tasks. Here's an example of a cleaning task for the code that's living on the hard drive. The key part I wanted to make clear here is that we don't clean at the end of your jobs. Always clean at the start. The reason for this shift is because if you have a failure on your job, you don't want to clean up the machine. You don't want to automatically clean up the machine, because then all of the evidence was gone as to why your build is failing. And so what we do is do it at the start. The outcome is the same, but we get the benefits of debugging. Moving on to linting. Linting is part of the static analysis phase. It's very valuable to get quick and early feedback on your code to make sure it meets standards compliance, and it also is syntactically correct. Some of the benefits of linting are that you get early feedback way before your Docker build or your npm install processes. There are pre-built Docker images for the linting tools already on the internet, so you can just pull them down and then take your code, put it into the container, run the linter, and get the results. This can help cut down the amount of time of your feedback cycle and spotting errors much earlier in the process. And also, there's a Dockerfile linter in which you can actually lint your Docker files before even trying to do Docker builds. Now we're on to the Docker build phase. Now the important thing to take away from this slide is the fact is we're always preparing ahead of time. By preparing ahead of time, we're cutting down the wastage of time between the phases in our pipeline. In this example, you can see we're doing our Docker build, but there's other Docker images here that future steps in our pipeline actually need. For example, in the integration tests, we need MySQL, Redis, etc. for them phases. So whilst the Docker build process is running and it's taking like 2 minutes of time, you can actually pad things into that 2 minutes of time, so that then you don't have that time penalty later in your pipeline. Now that we're on to Docker building, I just want to give you a few quick tips when it comes to doing Docker builds. First of all, try to avoid cloud-based providers who want to do Docker builds for you. These in general are fine. But if you're in a scenario where you already have the code onto your CI worker and you already have Docker installed, then just go ahead and do the Docker build. Otherwise, you're going to then have to initialize a cloud-based build that's going to take lots of time. It's going to be slower to execute the Docker build because the hardware in which you're getting your Docker build process from is slower. It's shared hardware, and you'll often find that you're in a queue. Based on how much money you pay these companies, they will put you in queues, and you don't want to avoid that. So you can just immediately start building. When you're doing your Docker build, give your CI machine enough cores to do the one or many Docker images that need building. Give yourself 32 cores. A spot instance is very cheap on Amazon. I mean, you won't hardly even notice the cost in compared to other solutions. So because of this, go ahead and do your Docker building. When you're doing Docker build command and you give your Docker image a tag, this is my recommendation, for a simple recommendation for creating a tag. It's get branch name is the name of the function. All it does here in Jenkins is Jenkins can build pull requests and it can build branches. So this code just checks, are we in pull request mode or branch mode? And then the important part here is that it replaces forbidden characters that you are allowed in your Git branches, but you're not allowed in Docker tags. So we'll just replace them with a hyphen, and then that will be clean and acceptable going forward. One last thing, when running the Docker build command, add --pull. Research this flag. It's going to pull down other images. It's going to keep things up to date. So I recommend you research this. Also, as soon as you have a successful Docker build, push that image to the registry. Don't wait till the end of the pipeline. And that means that you can pull that image down onto your local machine and you can debug the code. Here we go, moving on to a harder topic of CI/CD. This is where it's really important to get things right, and it's very easy to get things wrong. Test suites are usually the slowest part of any pipeline. And so the type of those test suites, the quality of them, the way in which you build them, and if you build them with the intent of how you're going to execute them on CI, will give you really good results. Here's an example of a project, right? These test suites are being executed in parallel, right, rather than sequentially. Now, as you can see here, I'm using Docker Compose, and I'm saying, right, well, we need a database and a Redis and a RabbitMQ and a web server. But this API test definition, I have one definition for every one of the test suites. Okay. As you can see, I have an entry point script. So this entry point script is going to be, so rather than your application by default running PHP or a web server or whatever it normally does, you can override that and execute your test suite. But the point here is that you want to have your databases and everything available so your test suites can execute it normally. By default, when you have Docker Compose and you say Docker Compose up, then you're going to get all of the services, right? And there's going to be one Docker network that's created by Docker Compose, and it's all your containers are going to be in the one network and they can talk to each other. Now, when it comes to something like this, these individual test suites, we need to make sure that they're isolated, because the database for the UI test suite was probably not going to play nicely with the API test suite and vice versa. And so we need separate databases for this. And the way we do this is we achieve network and container isolation between each project. Docker Compose has a flag called -p. -p basically is a project prefix in which to apply to Docker networks and containers. And normally in Docker Compose, it is default underscore. So if you've been using Docker Compose before, then you will see that it has default underscore and then the name of your containers and the name of the network. And so what this means is we are executing it says --rm API tests --rm UI tests. So that's the different service name in the YAML file, which has their own respective entry point script in which to execute the respective test suite under the hood. So now that we have our test suites are running in parallel like this, what happens when each of the test suites are slow? You cannot make them faster because they can only go as fast as they can go. Often you cannot activate parallel mode in these test suites because they are relying on the database state, and if you have two tests running in the same test suite at the same time, the data will get messed up and the test suites will not be able to function. And so the way you can solve this is by using segmentation. Segmentation takes an existing test suite and you break it down into smaller parts with 1-1, 1-2, 2-1, 2-2. Here in this example, I'm separating based on directory. You can also separate on tags. For example, if you're using BDD or Gherkin scenarios, these scenarios have tags on the top, so you can target things by tag, maybe not necessarily by directory. In this case, we're attacking that by directory, and therefore, if you have a test suite that takes 1 hour to execute, and you split it into 5 parts, in theory, with the right hardware, you can get that down from 1 hour to 20 minutes. So to recap, when trying to make your test suite run faster, try to parallelize the running of your test suites. If you have tools like Cucumber, Protractor, PHP-Unit, enable their parallel settings. Try to get it to run in parallel. If you cannot, then you can segment them into smaller parts. And if you're doing UI testing, then your bottleneck may not be the tests, but the number of browsers that are running actively in the test suite. So you can scale up the number of Selenium browsers that are running, and therefore you can get higher results. At the end of your pipeline, you will want to run some things. For example, you want to notify Slack when you have a successful build or a failure build. This is an example of my Slack message, which I have with links and handy stuff. All the information you probably need about knowing about a build without actually clicking into Jenkins. You can read it from Slack. Also, if you remember earlier, we are fetching our Git repository without any tags. So in this example, when the branch is master and only master, then we fetch the tags. This can actually take up to 5 minutes, I have seen in some repositories, just to fetch the tags. Then you can create your tag and then you can push it. When you're doing CI debugging, it's important to remember to leave the hard drive intact and don't wipe the workspace at the end of the pipeline unless it's a successful build. Also, if you're having failing tests for the UI and you're using Selenium browser containers, you can enable debug mode on these browser containers, and therefore they will run a VNC server inside of each container. And what that means is you can then download a VNC client from your machine and effectively remote desktop from your local computer into the CI server, into the specific container, and using SSH tunneling, securely attach them together, and therefore you can see exactly what's happening and inspect the situation and try to solve it. And it's a very, very effective tool. Security is really important, especially on CI and CD. When you're doing CI and CD, you're going to need access to secure information, such as usernames and passwords, or secure tokens to do operations such as change or manage your production infrastructure. Here's an example of a Gatling load testing script that I have created that you can execute on pre-production or production that goes around and performs load testing. But this needs a username and password. But we don't want to in plain text, so in the code base, store the username and password for production. And so what we do is we store these in the Jenkins credentials manager, and we access these using the with credentials keyword here. And then we get a username password multi-binding, and therefore as an environment variable to my bash script, I have access to gatling_login_user and password, and therefore that's a secure way to temporarily use secure information without it actually being persisted or stored on the hard drive. Another thing about security is commonly when you're doing your Docker build. When you're doing a Docker build, you're probably pulling down dependencies from the internet using npm install or composer install. Now, in this situation, we need access to our own private repositories. And so for this we need either SSH keys or we need special tokens. These tokens are placed in this auth.json file, for example, or SSH keys are being provided. If you look here, we see Docker is using something called BULDKIT. BULDKIT has secrets and SSH is part of the Docker file. So I recommend you research this further and how you can securely build your Docker images and use secret information, but it's never stored in the Docker image that actually gets shipped around the internet in the end. But it is important to know that you can do this now in Docker land with BULDKIT. Before we move on to the last part of the talk, I wanted to do a quick recap of what we've covered so far. We've discussed understanding and that you have and need infrastructure to power the right types of pipelines. Different pipelines have different hardware requirements. Tips on making Jenkins work very fast in terms of activating optimized mode in Jenkins, but also the Git settings for no tags and for shallow cloning will get things happening much snappier, much more responsive. Linting tips and feedback. Having the mentality of always prepare for time, and where there is extra time you're waiting, you can pad that time in there for the future steps. Running your test suites in parallel will cut down a significant amount of time, but when you have when you have test suites that are still slow, and you cannot parallelize them, then you can use segmentation to break them down into smaller pieces and run them in isolation, and you can start to break down test suites much easier, and therefore you can also refactor them in smaller pieces. With a focus on debugging and maintenance we've had so far, you're about to see more focus on debugging and maintenance in the final phase. And lastly, where possible, try to avoid cloud systems and build your own Docker images, because you have everything you need, and that will cut down a lot of time. So now we're going to move on to the last part of the talk about developing high quality pipelines. Here's an example again of another pipeline. It's a very busy pipeline, there's lots of things happening. So it's important to keep this stuff under control and to have quality in mind and feedback in mind also when building this pipeline. Otherwise, it will take a long time to build and maintain this pipeline. Here's an example of a structure that the Jenkins declarative syntax has. It's very clean, it's very simple. It's very similar to the YAML syntax you see on other projects, other providers of CI systems. Here's an example of what you don't want to do in your pipelines, which is put the shell commands directly into your Jenkins file or into a YAML file if you're not using Jenkins and you're using Bitbucket or whatever, right? You cannot take this code and you cannot run it outside of the pipeline. It's locked into the pipeline itself, and it will probably contain variables and information that only exist within the context of the pipeline file and not outside of the pipeline file. So vendor lock-in is bad. We know this from the software industry. The point is now you cannot rerun the tasks on the CI box directly or localhost because the commands are directly locked into the pipeline file itself. And therefore development time, when you're developing or maintaining the pipeline, the feedback cycle is very slow because you cannot run each part of the pipeline in isolation, and that's what you want to do. And therefore you cannot do TDD on building pipelines. Good things are, a good way to manage this is to have steps. Steps are basically the shell commands you already had in your pipeline files, but now we have abstracted them away into clean step files. So now we can run parts of our pipeline in isolation. This part is how we break the coupling from the vendor of the pipeline to the actual work happening. Okay, when you break that coupling, then you can execute each step in isolation independently, and you no longer actually need your CI software mostly. And so here's an example of what your Jenkins files will look like. Very clean, very simple, easy to read. When we're executing, for example, the unit test.sh, this is what it will look like on the inside. It's basically like running the code directly, but now you can run this command, this shell command, run unit sh on the CI box itself. You no longer need Jenkins to do this for you. You're in control and you're in charge. You can also therefore run this on your local machine. As long as you have Docker installed and you have the right images, you can go ahead and you can do docker compose run. And in this case, we're running a service called unit. Let's take a look inside what the docker compose YAML means when we mean unit. Unit is just a name, effectively, of a test suite. We have unit, end-to-end test, API test, integration. Each of them will have their own service. Now, if you notice here, it's not the entry point is basically the command that will execute and be the exit code of the docker compose run. So if the test suite fails, it produces an exit code of non-zero to bash. Therefore, this unit.sh will fail, and therefore going back, this command will fail, and therefore the Jenkins step will fail. So the exit code is preserved and it bubbles all the way up. Let's take a look inside what unit sh is. So going back a little step again, here is a scripts. Now the scripts is different from steps. Steps is what Jenkins executes. Now from the Docker Compose perspective, unit sh is in a file that's inside the Docker image. Okay. These are examples of our scripts. They're really just abstractions and ways to repeat the process on CI of running the independent test suites. So here's an example of a script file. It's doing 1, 2, 3, 100 different steps. It's basically an end-to-end file encapsulating all the things required for running that test suite. And in this case, they're copying an env file and we're running a unit test script. In addition to running the test suites, we have to understand that these test suites, they produce artifacts. These artifacts are code coverage files or JUnit output XML files or test reports. Now these files are getting created inside the containers, and because we're using volumes, we want to persist those files from inside the containers back out to the outside world into our CI box, right? The problem is the user that's executing the command inside the container has a different user ID in Linux to the ID on the host. And there's many solutions around this. This is a very well documented and covered topic of Docker. And so basically what I can recommend is that you create a user that you can use just in CI or in general that has a user ID of something like 1000. 1000 is basically the industry standard ID. It comes on Ubuntu, it comes on the Mac, and most Jenkins CI systems. Therefore, the user ID in the container is UID 1000, and the user on the host, which is the Jenkins worker in this instance, also has the ID of 1000. The IDs match up, and therefore, after your test suite is executed, you can then do things like this in Jenkins, which is, hey, I've now got files on my hard drive, and I want to run things like JUnit and archive to save the artifacts. So that's important to understand about permissions. And if you're trying to clean up your Jenkins job and you're getting permission denied, cannot delete files, it's probably because of this issue. Thank you for your time in coming to my talk. I hope you learned some things. I do consulting in this topic. I provide companies and teams with support, training, and workshops in order to build pipelines yourself, as well as helping them build them for you. So if you're having any issues, you have slow pipelines, you're having issues with your pipelines, you can contact me via email, Twitter, LinkedIn, and of course you can ask me questions on the QA here at the CDCon conference. I hope that we covered enough topics on a small amount that piques your interest enough to go and research and learn more about these topics. And if you would like to know more, then please get in touch. I'll be more than happy to help you out. Thank you and take care.